Hello everyone. In today's session, we're going to talk about dictionaries. A dictionary is a collection of data. In last session, we used lists, and list is a collection of data. Dictionary is also a collection of data. There are similarities and differences between lists and dictionaries. We're going to take a look at those similarities and differences. We also will check how to create dictionaries, how to add items to the dictionaries, how to manipulate the dictionary items, or how to traverse through the items, and some functions that can be used with dictionaries. Okay. So, collection of data. As you recall, in lists, we have seen that by using one list name, we can put a number of values in one object or in one list. We can put just one value in a variable. But in a list, we can put many values. Those values or items are separated with comma. In dictionary, also we can put many values. So dictionary is a collection of data. We can access the items individually, and those items are separated with comma. Okay, if you recall, a simple variable such as x in here, it's an ordinary variable. If we put the value 2, it stores the value 2. When we put the value 4, the previous value 2 gets lost and it is overwritten with the new value 4. So an ordinary variable can hold just one value. On the other hand, a collection such as list or a dictionary, they can hold multiple values. There are differences between lists and dictionaries, and there are similarities. List is ordered because list can be accessed by using index, which starts from 0 and then 1, 2, 3 up to the last item. So a list is an ordered collection of items. On the other hand, a dictionary is also a collection of items, but it's not ordered. That means there is no sequence. We can say that this is the sequence of the items. There is no such sequence. We can access randomly, and we can put them randomly at any place. A dictionary item is a collection of different type of objects, and different type of objects such as integer numbers, float numbers, or a string. But instead of using index for each item, they have labels. Okay, so each item has a label and a value. Those labels are called key. So a dictionary item is basically a key value pair. A list item is an index and value. We can access those values by using index. On the other hand, dictionary items does not have that kind of index, but they have keys, and keys are very similar. Functionality wise, they are the same. They have keys and values. Dictionary is a very powerful data collection, and it allows us to do database-like operation. Now, this term database might be new to you, and it is a convenient way to manage a large amount of data. For example, the students' data is usually put in a database, and individual student information, their courses, their marks, all these are put in a database. Now, dictionaries allows us to access or to do database-like operations such as to retrieve data from the database. So this kind of operations are convenient when we use dictionaries. Or PHP, Java, .NET, C#. These are different computer programming languages, and the concept of dictionaries might not have exactly same name dictionary, but they might be used with a different name. For example, a similar concept is known in PHP or Perl, associative arrays. In Java, it's the hash map. In .NET, property pack. So all these associated array or hash map or property pack or dictionary, they are similar concepts. Okay, so different languages, they have different names. If you remember, in last class we learned about lists, and we did see there are two different ways to create list. For example, let's say L1 is a list, and then we put equal sign or assignment and then a square bracket. In a square bracket, we can put different values. So this becomes a list. For example, 3, 7, 12, 6, 34, 8. So this L1 is a list. It is assigned a collection of values in a square bracket, and those values are separated with commas. There's a list. Now, if we think about the position of these values, then we can say there are indexes starting from 0. The value 3 is at index 0. The value 7 is at index 1. So these indexes are always fixed. It always start from 0. Okay, in list. So this is list. This is one way to create list. Another way we can create list is to use a constructor function. So let's say L2 is another list, and then the function name is list, and then a parenthesis. L2 is an empty list. Okay, and then we can add, let's say L2 dot append. We can add values with the list, and let's say appending 22. Okay, and L2 dot append, and I'm adding, suppose I'm adding 32. Okay, so the list L2 has two values. One is 22 and the second one is 32. The index of value 22 is 0, and the index for the value 32 is 1. If I print the list L1 and also print the list L2, then we'll see these items start with the square bracket, closes with the square bracket. The second list L2, 22 and 31. Now the index of the first item is 0, index of the second item is 1. It doesn't matter what is the content, always starts with 0 index, right? So this is how we create and use list. On the other hand, we can create dictionary. So we'll see differences and similarities. Okay, so let's say dictionary D1. We can create a dictionary by using curly bracket, not square bracket. So it will be a curly bracket. Okay, so this is an empty dictionary. Or we can put values as well, similar to this one. Okay, however, since there is no index concept in dictionary, but we need to find the items. So we need to use a key and value combination. Okay, so let's say key 1 and then a colon, not a comma, a colon, and then comes the value. Okay, so let's say the value is 3. This is one item, but this key 1 is a string, so I need to put in a quotation mark. Okay, so this is key 1. Key is you can imagine key is the same as index, but without a number. It's a text. So key 1 is the key, and that you can imagine this is the first position, but there is no order. When we say there is no order, that's why I don't want to say first position, but this is one of the item that can be identified by using key 1, and its value is 3. So this is one item. To add a second item, I will put a comma similar to list, and then again another key 2, a colon after the quotation mark, a colon, and then the value 7. So I created a dictionary D1 with 2 key value pairs. So essentially these are 2 items. In the list case, we did not have the first part because it's something already predetermined. For example, in the list, the index 0 is already predetermined. There's nothing else, it's 0, it's known. Okay, predetermined index 0. In dictionary, we don't have such thing as index. It's something that we define, we determine, we fix what to use. Okay, so we can give any name here. I gave key 1 as 3 and key 2 is the second item as 7. So we have created a dictionary similar to this one, and then if I print dictionary D1, it will print. I can also create a dictionary in the same way I created the list. This is another way, by using the constructor function. So I will use D2 equals DICT. Okay, that's the function name, DICT, and then parenthesis. So this is a function, as you can see, DICT is a name, and then you have parenthesis, which is a structure or skeleton of the function. Right? So this constructor function, list also used constructor function, and D2 became an empty dictionary. Okay, here list was an empty dictionary. In list, we did append different values. In dictionary, we can also append, but there is another way to add items. Let's say D2, and then we have to mention the key. Instead of index, we need to mention the key, and in square bracket, similar how we mention index. We did mention index in list in square bracket. Here also mention the key in square bracket. Okay, and then quotation key 1 equal, let's say 8. Now this is dictionary 2. Okay, first one was dictionary 1, and this one is dictionary 2. So they are 2 different dictionaries. Now key 1, this was an empty dictionary, and then when I assign key 1 a value, the dictionary D2 will look if key 1 already exists in the dictionary. If it does not exist, then it will create a new item. Okay, it's similar to creating a new item like this. Okay, and thus assign a value to a key that adds one item similar to this concept. Okay, now here is a key difference. There is an important difference between dictionary and list. When a key does not exist in the dictionary, that item of key value pair, this is the key, this is the value. This key value pair, here is the key, this is the value. This is the key, this is the value. When you add an item, you need to add both key and value. Both are determined by us. In list, index is already predetermined. We don't need to say, we don't say, we just put the value. Okay, so index 0, this one index is 1, index 2, and so on. Here, there is no such thing as index. Okay, and whether I would put key 2 first or key 1 first really doesn't matter. So there is no sequence. Okay, it's not ordered. It can be in any order. So a key difference is that when we put an assignment like this in dictionary, it looks for this key value pair, for this key actually, and if it does not exist, it will add this key value pair. But in list, this type of assignment for an index which does not exist will create an error. For example, let's say list 2. If we think about list 2 has 2 items. So the index is 0 and 1. Okay, that means index 2 doesn't exist. If I try to use index 2 and put some value, let's say 44, this is gonna create an error because this index 2 for list 2 does not exist. This is index 0 and this is index 1, but index 2 does not exist. Okay, in dictionary, when an index does not exist and you assign a value for that key, this key value pair gets added. It's not an error, it gets added with the dictionary. When you try to assign a value, assign a value, it's important that you are assigning a value. The difference is there. When you assign a value and that index does not exist, it's gonna throw an error. Okay, let's print dictionary 2. Now we're gonna see what happens. Okay, let's run. You see there is an error on line number 8, and this is line number 8. This index 2 does not exist on list 2. It indexes at 0 and 1, 2 items, so index 0 and 1. So index 2 does not exist, and it throws an error. Here, when I assigned a value with key 1, which also does not exist, right? It's an empty list, empty dictionary, so this doesn't exist yet. But this will not throw an error, rather this will add a key value pair. So I'm going to turn this off so that the error is removed, and then we'll see what happens here. Now we see everything looks good. We have the first list, this one was printed. The second list had 2 items, index 0, index 1, index 0, 1, 2, 3, 4, 5. Okay, 6 items, index 0 to 5. 2 items, index 0 to 1. Here, there is no such thing as index, but there are key and value. This key is also our defined. Key 1 is the first item's key, and 3 is the value. Second item, key 2, and the value is 7. Dictionary 2 is an empty dictionary first. When we assign a value for a key that does not exist, this key value pair was added with the dictionary. Okay, and then we print the dictionary and we see the list of items. So you see a key difference when there is I'm trying to access a position with index and change the value of that position, it throws an error. In dictionary it does not, rather it adds an item. Now I can of course use an existing index. For example, for L2 I have 2 values, so index 0 and 1, so I can change the second item to 44. That should be fine. Okay, let's run. You see the second item became 44. Before print, I changed the second item, index 1 is 44. Initially it was 32. Now I change it to 44 and I could use it. Okay, because this index exists. And if I use an index that does not exist, that means we don't have that value on that index, then it throws an error. In dictionary, it's not. It does add an item. Okay. Now, each key in a dictionary is unique. That means you cannot have two items with the exact same key name. I will show an example here. I said key 1 is 3 and then again key 1 is 7. Okay, it identifies that key 1 was used in initialization twice, so it does throw an error here. However, I can try to change key 2. I will, let's say I want to add something like this. Okay, so I will say D1 key 1. Okay, key 1 equal, so 10. Now, since we have seen that if a key does not exist, it automatically gets added with the dictionary. This key already exists. Key 1 is the key. Key name is key 1, and we have created key 1 before. So when assign this value, this key 1 does exist, already created before. So this will change the value for that key. That means this 3 will change to 10. Okay, so when we print, we'll see 10 and 7 because we changed the key, the first items that we referred with key 1. So it essentially referred to this item when we say key 1, which already exists. So the change value will affect this item. Right? You see now we have 10 and 7. Okay, for dictionary D1 and dictionary D2 as we saw before. Okay, let's go back to. So I've seen we can create a dictionary by assigning a key value pairs. Okay, in a curly bracket. In list we use square bracket. In dictionary we use curly bracket. We have created an empty dictionary by using the function dict, and it's a constructor function similar to list, and then we can add more and more items. Okay, when we print a dictionary, it shows curly brackets. Okay, the dictionary is in curly bracket. When you print a list, it shows square bracket, right? Okay. Now, sometimes we use more practical keys. For example, let's say D3. I'm creating another dictionary. Okay, D3 equal, and I want to use brand, and value is, I used number. Of course I can use string as well. Value is 4. So the first left side of the colon, this is the key, and the right side of the colon, that's the value. Okay, we used number before, now I'm using string. So this is one item in the dictionary. I want to add another item. Okay, and so first comes the key, model, and then colon, and then the value. Okay, So Ford is a car brand in North America, and Mustang is one of the models. Okay, and let's add another item here, colon, and then value. Let's say 2018. So the dictionary D3 has 3 items. These 3 items are separated with comma. See, after first item there is a comma, after second item there is a comma, and there is the third item. I have used the keys brand, model, and year, and their corresponding values are Ford, Mustang, and 2018. Now if I do print D3, dictionary 3, I'm going to see those key value pairs. Okay, brand Ford, model Mustang, year 2018. So we have seen some similarities between dictionaries and lists. Also, we have seen some differences between dictionaries and lists. So here, parse is a dictionary, used the constructor DICT to make it, and then money is the key, 12 is the value for this key, candy is the key, 3 is the value, and then tissues is the key, 75 is the value. When you print, you see those key value pairs. Okay, and if you want to access any specific item, you can access by using that key. Here in the list, so let's reduce the content from this page and let's make it shorter. Okay, so we have one list, one dictionary. Okay, now I want to print only the second item. Okay, how can I do that? In list, print, and then the list name L1 and index. So the second item index is 01. Okay, that will print the value, second value of the list. Similarly, if I want to print the second item from the dictionary, then I will use print dictionary name D3, and then instead of index in square bracket, the key in square bracket model. Okay, so but remember, key is a string, so you always have to use a string D3, not D1, D3, dictionary 3. Okay, so here I will turn off the whole list print as well as the whole dictionary print. I'm only printing the second item here, and there is no such thing as second. I could put the model anywhere. I could put it at the beginning. Will not make any difference. I could put this model at the end. Will not make any difference because we are accessing by its name, not by its position. Okay, this one has position 0, first position, 1, second position, 2, third position. This one, there is no positional concept, but each one has a name, which is the key. Name is model, which is the key. Now, if I print model, it doesn't matter where it is, it will find that model from the dictionary and will print its value. So if I run, you see that I printed index 1, second item. So I printed 7. I printed the model, which is similar to index, but it's not really index, it's called key. and it can be anywhere. Okay, so there is no concept as in list where we have index. So there is no position concept, but name concept. Okay, it's a name. So we refer by name now, and that's called key. All right. So also we can use it in expressions. So let's make a dictionary with some K1, 5, K2, and then 10, K3, and then 15. Okay, so D1 is a dictionary with 3 items, and each item has a key value pair. Now I can use other mathematical expressions if we are dealing with numbers. Okay, the number can have mathematical expression. So let's say I can change the value of this one. So I will say dictionary ones, and then in square bracket the key name is K2. That's referring to this number. Okay, we call this name, but when we do any operation, it applies on the value. So if I change something to something, it will change its value. So if I say 15 here, okay, that will change these keys corresponding value. When I print the list of index 1, so it shows the value of that position. When I print the key, okay, it shows the value. So if I change the K2 keys value with an assignment, it will change the value. Right? Now let's say print. I'm printing only that key K2, so that should show 15 now after it changed to 15, right? D1, so 7, 15, I printed K2, which was initially 10, now it became 15. I can use also mathematical expression. So let's say the current value, how do I say the current value? With exactly the same expression as this one. The current value is D1 and K2. This is the current value. Okay. Remember when we use a variable on the right side, it uses right side of an assignment, it uses the current value. When we use a variable on the left side of assignment, that variable value changes. Now what I'm going to do is I'm going to change the current value or increase the current value by 2. Okay, so current value plus 2. So this value, this K2 value will change to, it will take the current value and then add 2 and then replace the current value with this new value. So this value is expected to become 12. It was 10, now it became 12. Okay, if I add 8 with this, so it will use the current value, which is 10, add 8 with it, so this side becomes 20, and then we'll change that position, that key's value to 20. Okay, so this item will change to 20, and when we print that item, that will show 20 here. sorry, 10 plus 8, 18, not 20. Okay, so we can use dictionary items by referring to the key. Okay, there is no such thing as position in dictionary. It's the key. In list we have position, or it's known as index. Okay, we have seen this kind of example. This is a list, append. Okay, so if we compare, in case of list we have key, which represents the position. Okay, and we have corresponding value. In case of dictionary, there is no such thing as position, but it has keys, okay, or name of each item. Okay, all right. I have explained this. Okay. There is a problem that we want to solve. So these are some of the names, okay, that appeared in a list of names, or some of the words you can say that it appeared in a list of words. Now we want to find out the most common name. So let's say you have collected name of thousands of people, and you want to find out which name is the most common in that region or in that country. Okay, so what you will do, you will go through the list of names and you will identify each name, each unique name. Okay, and you will keep counting each unique name. If you see a name for the first time, you will say count is 1. If you see that same name second time, you will increase the count to 2. If you see the same name third time, you will increase the count to 3. Okay, so these are some of the names. So we'll read from the beginning until the end horizontally. Okay, this is the first name and it appeared the first time. So we can put this in a key. When we read this, we will find out if this key does exist in the dictionary. So you can create a dictionary. Okay, and if we create a dictionary, let's make so now I'm going to create a dictionary. Text white and larger text. So first word I find, I put that in as a key. Okay, this is the key, and the value I put as a count. How many times I found this word? Once. So first time I put that, I encountered that key, okay, or that word, I put the count as 1. I read the next word. Is this a new word or is it an existing word in the dictionary? It's a new word, that means it's a new key. So I'm going to add that in the dictionary and put a count as 1. Next word. Is this an existing key in the dictionary? Yes, it is. We already have that in the dictionary. So I'm going to increase the count by 1. Okay, so I will change this value to 2. I increase the count to 2. Next, is this a new word or new key in the dictionary? Yes, it is a new key. So I'm going to add that key and increase the count. Previously I did not have any, so count was 0, or now increase it to 1. You can say it that way, or this is the first time I encountered it, so I put it as 1. Next, is this a new word or is it an existing word in the dictionary? It's an existing key in the dictionary. So I increase the count by 1. So this becomes 2. Okay. In other words, I take the current count or current value and increase the current value by 1. So it becomes 2. Next, is this a new word in the dictionary? No, it's an existing one. So take the current value and increase it by 1. So it becomes 2. Okay. And then go to the next word. CSEV. CSEV, we don't have that in the dictionary. So I'm going to add that key, CSEV. Okay. And existing count is 0 because it didn't exist, right? So increase the count by 1, so it becomes 1. And then ZHEN, it's not a new word, it's already exists in the dictionary. So we'll take the current value, which is 2, and increase it by 1. So this value will become 3. And then another word, I think this one, CSEV encountered second time. So increase the current value by 1, it becomes 2. And then we have this word already in the dictionary. Take the current value, increase 1, so this becomes 3. ZHEN, take the current value, increase 4. CSEV, take the current value, increase by 1. And then ZHEN, take the current value, increase by 1. Now if I look the maximum value in the dictionary, I find that ZHEN appeared the maximum. Okay, the value is maximum for the key ZHEN. So ZHEN then is the most common name in the sample. Okay, it's used the most. Got the concept. So we want to find out each name appeared how many times. I explained how we got that. Okay. Here is the actual algorithm. Okay, so initially we have that list that we saw in previous slide. This list. Okay, that list is here, and it's a list. So it's put in a square bracket, and the name of the list is names. I'm going to bring that list at the top. Will not make any difference in terms of the algorithm or output. So I'm going to bring that to the top. Okay. Now then start with an empty dictionary, and the name of that dictionary is counts. Okay. Then for name in names, that means we are traversing through this list, or I like to use a different variable name just to avoid confusion. Sorry. Confusion between name and names, sometimes I get confused. So I like to use a different variable. So here, the given list, and you can imagine this is the list of name of people. Okay, Then we want to find out which name is the most popular. So we start with an empty dictionary, and then we access each of this name by using a for loop. In the same way, we accessed a list. So for A in names, so the variable A will pick up every single value from the list. And then we'll check if this name does exist, okay, if this name is already in the dictionary. So how am I checking? If that A, or this name, A will pick up this value first. If A not in counts, if A not in this dictionary, if A, CSEV, is CSEV first time, is not in the dictionary, which is counts. If it is not in the dictionary, then add a dictionary item, counts is the dictionary, add a dictionary item with this key, which is A, okay, add a dictionary item with the first value as a key and put the value as 1. So it after doing this, it will create, let's copy this, it will be easier. So we start with an empty dictionary, okay, empty, and then for A in names, so A takes different values in the loop. First time it takes CSEV, second time in the loop it takes this value, third time it takes this value, okay, fourth time it takes this value, fifth time it takes this value. If A, so first time we're coming into the loop, A, which means this value, not in the counts, this dictionary name is counts, okay. So this is the counts is the dictionary. If A, which is this value, is not in the counts, yes, it is not in the count. What it does, remember the dictionary name and in square bracket the index equal 1, that will create an entry. So it will create a key with the name as the A value. So the key would be CSEV and its value would be the assigned value. So this becomes 1. In other words, we did not find this word in the dictionary, so we added that word and added the count as 1. Since if part was executed, it doesn't go to the else, so it goes back to the loop. Now A will pick up the second value. Now A is CWEN, okay, A is CWEN, and then if A not in dictionary, is CWEN is dictionary? No, it's not in the dictionary. So since this condition is met, it adds that item in the count, it adds that index, okay, which is CWEN. So sorry, CWEN, this key and value as 1. Since this part was met, this condition is met, this statement is executed, else will not get executed, will go back to the loop. Now A will take CSEV value. Now it's checking if A not in counts. Is A not in count? No, that's not true. A is in count, right? This CSEV is already in the dictionary. So this is not true, so it comes to the else part. And when it comes to the else part, what it does, it changes that index, which has A value, that means this item to the current value, which is 1 plus 1. So current value 1 plus 1. So this becomes 2. It goes back to the loop, takes this value, looks in the dictionary. If it does not exist, it creates a key and then add the value as 1. Okay, next word with this one, it does exist in the dictionary. Okay, and if it does, then it comes to the else part and it takes the current value, which is 1 plus 1. So it makes the value, changes that key's value to the current value plus 1. Current value was 1 plus 1 makes 2, so it changes to 2. This is how we can count each of these words, how many times each of these words appeared in the given list. Now the given list could be list of thousands of people, given list could be a text file, given list could be a sentence, and you want to find out which word appeared the most in a sentence or in a paragraph and so on. Okay, now whether in this algorithm we have seen that we picked up one value and checked if that key does exist in the dictionary. This type of checking is used in Python so many times that they created a function. Okay, the function name is get. So it's used as the dictionary name dot get, and this is the key you're looking for. Okay, dictionary name dot get in parentheses the key that you're looking for. If it does exist in the dictionary, it returns its value. This key exists. If it does exist, it has a value. If it does exist, it returns that value. If it does not exist, then it returns whatever value you want to put here. Normally we'll put 0. Okay, but you can put any other value. That's the default value. So the equivalent code is if else. This if else equivalent is this one line. Okay, this kind of if else, what it's checking, if a name, which is a key, exists in the dictionary. Okay, if it does, then you find out its value and put it in X. If it does not exist, put 0 in the X. So this if else, what it does, changes the value of X depending on whether that name exists in the dictionary. Okay, if it does, get the current value. If it does not, then put a different value. That functionality can be achieved by using the get function of the dictionary. How to use it? The dictionary name dot get, and then the key we're looking for, that goes in the bracket, comma, if it does not exist, what value we want to use, that goes in the as the second item in the parentheses. Okay, and this X value will either get, if it does exist, then its current value, X will get the current value. If it does not exist, it will get this value. Okay, it doesn't have to be 0, you can put any value, but 0 makes more sense in our context. Okay, now so now instead of using if else that we have used before, if in counts or if it's not in counts, okay, you can use either way. You can say if in counts, then do this. If it's not in count, then do this. Instead of using this if else, now we're going to use that get function. Okay. Similarly, as before, if A will pick up these values, okay, when it does go through this loop. First time A is CSAV. If A or CSAV does exist in the count dictionary, count.get, that's the function you're using. If A exists in the count dictionary, then return its current value, okay, here, return its current value at this place. If it does not exist, return a 0, okay, and then our algorithm needs that the new value will add a 1. When we encounter a new item, we use either the current value or 0 plus 1. So if we go through this loop, first time A is CSAV, it does not exist in the dictionary, so we get 0 at this place, okay, plus 1. So the count of this name becomes 1, 0 plus 1, the count becomes 1. Go through the loop again, and then check this item for the variable A. Again, it's looking in the dictionary if CWEN does exist in the dictionary. It does not. It has just one value, which is this one we just added before. CWEN does not exist, so this get function returns 0 and then plus 1, so this whole thing becomes 1, so the count of this becomes 1, okay, so you got 1 for this. Now CSAV, when we get this count, when it executes this count.get with CSAV as the value of A, this time it does exist in the dictionary because it was added before and its current value is 1. So this function returns 1 and then add 1 with it. So this right hand side becomes 2 and the dictionary value for that index, so it should be A, not name, should be A. I changed the name to A, right? So the dictionaries, that key's value changes to current value plus 1, so which is 2, okay? So essentially we are counting each word and saying at the end we'll see each word appeared how many times in the list. All right. Okay. So let's try a little program. Okay. We're gonna get an input from user and we're gonna count each word and say each word appeared how many times. So I'm going to remove all this and let's say line input and enter some text. Okay, so the prompt, it will say enter some text. The user will be able to type in, and whatever the user types in, that goes in line. So we're gonna then check how many words in line. We'll separate each word and then we'll count them. Remember we used a function called split. So if I use line.split, that will separate each word from line. So I'm gonna create a list for this. Split actually does create a list. So let's say words equal this. If I print words, print and words, you will see the input that I type in, but with separate words. Our program is not done yet, so let's see what happens. This is my input for the program where we will count the frequency of each word. Okay, so I press enter now. You see it did separate. This is my input for the program where we will count the frequency of each word. Okay, that was my input. That was my input, but from this whole string, it did split the line by words and put in a list. As you can see, it's enclosed with a square bracket, so words is a list. Okay, now I'm gonna count similar algorithm as before. So let's say counts equal an empty dictionary. Okay, now I will traverse through this list words, which essentially I will traverse through this list with the for loop for, let's say, A in words. Okay, and then the dictionary counts the index is the same as each word. So index is A equal current count counts plus 1. And then finally I will print the dictionary itself, so counts. Okay, now this is my input for the program where we will start again. This is my input for the program where we are counting the number of words. Well, this is some graphics issue. I'm still typing, but it did not refresh. It's because it's online. Anyway, we'll see of words. I will add one more sentence. Okay, now I press enter. Something was wrong in there. Where was it? I remember. Oh, what do you see? Here I did make a mistake here. Counts A is essentially this may not return a value, so I have to find out whether it exists in the list, or if it does not, then I have to use 0 plus 1, right? So I did not use the function, or I did not use either if else. So I will use the function counts dot get, and then A comma 0. A is the word. It will return what is the value for that word. If it's not found, then it will return 0. Okay, so now try to run. Okay, so I'm finishing my input, so I press enter. It did create the list starting from square bracket up to here. Now it did count each word. So this is the first word, appeared once, is appeared once, the appeared 4 times. Here is the, here is the, here is the, here is the. So it did appear 4 times, right? Input appeared once, 4 appeared once, and so on. Now you can have a very long text, and you can find out easily how many times each word appeared in the text. You can have a very large file. Okay, so what else do we have? All of these concepts we already have used. There are some functions, okay, similar to list. List had some functions. Also, dictionary have some functions. For example, the dictionary name dot keys gives you all the key values: Chuck, Fred, Jen. So when you print dictionary name dot keys, it gives you the list of the keys. If you want to print only the values, okay, then you say dictionary name dot values function. That gives you the values, value 100, 42, 1. If you print items, that gives you both key and value, but in a different format. When you print the dictionary itself, not items, then it gives you the key colon value, key colon value. But when you print items, it also gives you the same information, but in a different format. So there are some other functions that you can use with dictionaries. Dictionary name dot clear, that will remove all the items. Pop will remove one item. Update will update a value for a certain key. Yeah, these are the main functions. There are about 10-12 functions that you can use with dictionaries, and they are specific to dictionaries. All right, so we're gonna finish here. Okay, take care everyone. See you in the next class.